Imagine a star so massive that if you replaced our sun with it, Earth would be inside the star. Actually, so would Mars, and Jupiter, and Saturn. The surface of this star would stretch almost all the way to Uranus. This isn't science fiction. This star is real. It's called WOH G64, and right now, something absolutely extraordinary is happening to it. For the first time in human history, astronomers are watching a supergiant star transform in real time. And what they're discovering is rewriting what we thought we knew about how the biggest stars in the universe live and die. Let's dive in. WOH G64 is what astronomers call a red supergiant. These are the largest stars by physical size anywhere in the universe. The final bloated stage in the life of a very massive star. After burning through its fuel for millions of years, a star like this swells up to enormous proportions and turns red because its outer layers cool down as they expand. This particular star lives in the Large Magellanic Cloud, a small companion galaxy to our own Milky Way. You can actually see it with the naked eye from the southern hemisphere. It looks like a faint, detached cloud floating in space. The distance? About 160,000 light-years, which means every bit of light we see from this star has been traveling toward us since before modern humans left Africa. When astronomers first spotted this giant back in the early 80s, it seemed pretty ordinary, just another cool giant star in a catalog. But then infrared observations revealed something stunning. This star was surrounded by an absolutely massive cloud of dust, and it was throwing off material into space at a truly absurd rate. We're talking about losing more mass in a single year than our sun loses in billions of years. For decades, it pulsated like a slow cosmic heartbeat, brightening and dimming over roughly 2.5 years. It seemed stable, extreme, yes, but predictable. And then, around the early 2000s, everything started to change. The star began to fade. Slowly at first, then faster. Those steady pulsations started getting weaker, more irregular, and the spectrum of light coming from the star, basically its fingerprint, started transforming into something astronomers had never seen before. Instead of the smooth, cool signature of a red supergiant, they started seeing bright emission lines, spikes of light from hot, ionized gas. That's strange. Red supergiants are supposed to be cool and relatively quiet. These emission features suggested something hot and violent was happening. By the early 2000s, WOH G64 had dimmed dramatically invisible light. It became something like 15 times fainter to our eyes. Something was blocking the star. Something was changing. And then came one of the most remarkable observations in recent astronomy. In 2024, a team of astronomers used the Very Large Telescope Interferometer in Chile, essentially 4 giant telescopes working together as one enormous virtual eye, to capture the first ever detailed image of a red supergiant outside our own galaxy. This was a genuine breakthrough. Getting enough resolution to see structure around a star this far away requires cutting-edge technology and incredibly sophisticated signal processing. And what the image showed was fascinating. Instead of a nice, round, symmetric cloud of dust as the models predicted, they saw something elongated, stretched out. A compact structure extending well beyond the star itself, glowing in the near infrared. The team realized they were looking at hot new dust forming extremely close to the star's surface. This dust was wrapping around it and blocking its light, especially at certain wavelengths. And this explained the dimming. They compared old observations from before 2010, which showed the classic water vapor features you expect from a cool red supergiant, with newer data from 2016 onward. In the newer spectra, those water vapor features had almost vanished, replaced by the featureless glow of hot dust. The dust formation seemed to have started sometime between late 2009 and 2016. It was the biggest change this star had undergone in all of recorded history. But here's where it gets even more interesting. that elongated shape wasn't random. It suggested either a jet-like outflow shooting material in a preferred direction, or possibly, and this is the exciting part, the influence of a companion star. Around this same time, some researchers proposed something dramatic. Maybe this star wasn't a red supergiant anymore. Maybe it had crossed into a rare evolutionary phase and was becoming something called a yellow hypergiant. If true, this would be huge news. Yellow hypergiants represent a post-red supergiant stage, a star that's already blown off enormous amounts of mass and is now heating back up on its way to an eventual supernova explosion. They're incredibly rare. Seeing one form in real time would be like catching lightning in a bottle. But then came new observations that changed the story again. Between late 2024 and late 2025, astronomers obtained a series of detailed spectra of the giant using a large telescope in South Africa. They watched this star carefully over more than a year, and they found something crucial. The molecular fingerprints of a cool red supergiant were still there. Specifically, they detected titanium oxide bands. These absorption features only form at low temperatures, in the cool outer layers of a red supergiant. If this massive star had genuinely evolved into a yellow hypergiant, those molecules would have been destroyed. The star would be too hot for them to exist. But they were still present. Shallower than normal, yes, suggesting an unusually extended and rarefied atmosphere, but unmistakably there. So this star is still a red supergiant. It hasn't abandoned its identity, not yet anyway. But the picture these astronomers pieced together turned out to be even more fascinating than just the star is fine. Here's the key insight. There seem to be two separate things happening in the system, and they're not varying together. The red supergiant itself, its continuous glow, was actually getting brighter over the year of observations. The dust obscuring it seemed to be thinning or shifting. But those emission lines from hot ionized gas, they were getting weaker relative to that background glow. If everything was coming from the same source, you'd expect them to rise and fall together. They didn't. The best explanation is that we're looking at a binary system. This distant giant has a companion star. The red supergiant is producing the cool molecular spectrum and the red glow. But the companion, which must be hot and UV bright, is producing all those emission lines by ionizing the gas around it. And this isn't unprecedented. We know of other systems like this, where a bloated red supergiant is paired with a hot companion embedded in a disk of material. It's just incredibly rare to catch one in this level of detail. Here's the scenario. As the companion star approaches on its orbit, its gravity tightens what's called the WOH lobe around the red supergiant. Essentially, the gravitational boundary that defines each star's territory. As that boundary shrinks, the already bloated atmosphere of the red supergiant starts spilling over. This mass transfer feeds the companion, building up its disk. It increases the density of gas around the system, triggering the formation of that elongated dust cloud we imaged. It causes the red supergiant's atmosphere to become more extended and rarefied. And it causes the visible surface of the red supergiant to shrink slightly and warm up, which explains why its pulsation period shortened and its color changed subtly over the past few decades. The dust cloud itself appears to be clumpy, with blobs drifting past our line of sight at speeds of tens of kilometers per second, creating the irregular variations astronomers observed. The orbital period of this binary must be extremely long, probably more than a century. That's why no similar dramatic events have been recorded in the entire history of observations going back to the 1950s. So where does this go from here? One possibility is that this star settles back down. The mass transfer episode calms down, the dust disperses, and the star resumes its old pulsating rhythm. What we're watching is just a chapter in its life, not the final act. But there is another possibility. Those atomic absorption lines from elements like potassium, oxygen, and sodium have been getting stronger, nearly doubling in just 1 year. That's a sign that deeper, hotter layers of the star are being revealed as the outer cool layers become more transparent. If this trend continues, WOH G64 might indeed be on its way toward becoming a yellow hypergiant after all. And if that happens, if it continues shedding its hydrogen envelope through this binary interaction, it could end its life in a very different kind of supernova than we'd expect. Instead of a typical red supergiant explosion, it might become what's called a stripped envelope supernova, the kind we think happens in binary systems exactly like this. We might be watching, in real time, the process by which a star gets fundamentally changed by its companion and set on course for a different kind of death. Think about this for a moment. This supergiant is 160,000 light-years away. Everything we're seeing left that star around the time our ancestors were just beginning to spread across the Earth. Whatever this star is doing right now, in the actual present moment, we won't know for 160,000 years. It might have already exploded. It might already be a neutron star. Or it might still be out there, slowly pulsating, surrounded by its dusty companion, doing what red supergiants do. But what's remarkable is that a small group of astronomers, using telescopes in Chile and South Africa, have managed to watch a star the size of our inner solar system change before their eyes, month by month, observation by observation. That's not just science, that's something close to magic. If you enjoyed this deep dive, hit that like button and subscribe for more space content. And let me know in the comments, what aspect of this story fascinated you most?